countdown. We did the thing that we do every week, plus or minus an hour at this time. But what were you going to say, Vlad? Our listeners are dying to know.
Well, I was gonna say, and so Pavel, I guess to give you some context, sometimes we had like very structured introductions to the stream, and sometimes we had, like conversations that are related to, let's call it, integration, manufacturing, and I would say like in this case, like the life of a systems integrator, and I think it's very difficult to have a solid, like diet when you're traveling a lot. You obviously have, I want to say, like very accessible, not the healthiest choices of food, and so I think it certainly is something that's not that discussed in our industry. But in any case, I'll let Dave introduce the
Thank you.
episode.
But before I do that, I want to give a little manufacturing hub behind the scenes for anyone who is unfamiliar. So just so everyone knows, and I think I've made this joke for long-time listeners, if you guys have ever been backstage with Vlad and we've ever agreed that we're not going to talk about one particular topic, Vlad is 100% going to ask someone about that topic. So if there's like a secret thing that you guys have coming out that you kind of want to like tease behind the scenes, absolutely do not tell that, but be to Vlad during the pre-show call, lest it immediately goes out live and on the air. But having said that, everyone, welcome to Manufacturing Hub. Very excited kickoff of the robotics theme today. We want to thank the folks at Solus PLC for going and sponsoring this, and the folks on camera with me will certainly have more to say about that when we get to it. But we'll let everyone know Solus PLC has, earlier at the beginning of the year, launched a whole bunch of robotics courses as well, and so we will certainly go ahead and talk more about that as we go. But very excited for the robotics theme. Very excited for the robotics team. So I guess without further ado, everyone, officially welcome to Manufacturing Hub. My name is Dave. This guy down here is Vlad. We want to welcome our guest, Pawel Krupa, to the show. Pawel, thank you for being here. Welcome.
Glad you guys having me.
Thank you so much for joining us today, Pawel. Before we dive into industrial robotics, could we get an introduction of how did you get into manufacturing? Ultimately, what was your career like and what it is that you do today?
Sure, of course. So basically, if we go all the way back to my technical school, I started as a technician of teleinformatics, which is kind of a mix of an IT, a little bit of electrical and mechanical knowledge. And going from there, I always thought I'm going to pursue the career in IT. However, when I went to studies, that kind of changed because that was the first time I've seen robots. So I decided, well, that seems like an interesting path. And back then, it was 2011, 2010. It was a pretty new subject, which wasn't very explored. So I was like, well, that's something that I can feel challenged with. And I liked the way how the teachers were doing all of the classes during the studies. And slowly, like this, I started getting more and more into the topic. And therefore, during my studies, of course, like probably most of us, were trying to make some money on the side. So I was doing many jobs. One of them was like pizza delivery, restaurants, like all of the stuff that people do during the studies just to get some extra money. And one day I spoke with a friend and like, hey, right now I'm looking for a job. I would like to make something on extra. And he was like, yeah, I know someone that is doing some hiring for like projects during the weekend. And it's for like robot programmer. I'm like, well, that sounds interesting. That sounds like something I want to do. So that's how I started. And then in 2011 was the first time I went to an automotive plant. I saw the robots and I can say I kind of fall in love with them. And that's how I started my journey. And ever since, I've been close to the robots and I've been programming them since 2011.
Awesome. And I guess, so you had an official curriculum or an official class that you took in your college, or was it a general class and then you had to maybe fill in with the, like with one of the manufacturers? How was that maybe learning curve for you?
So we had a class strictly on robotics during my studies. So it was in a curriculum of your studies. So I think in the second or third semester of my studies, there was a class that was assigned to robotics. It's a little bit different in Europe because you don't really choose the subjects that you would like to, at least in Poland. You don't choose the subject of all of your topics that you would like to get throughout your studies. It's kind of predefined. And then as you do your masters, the master is more leaning towards the subject that you're interested in. So basically, there wasn't much during my bachelor's degree, but then when I moved to the master, that's where I got a little bit more deep into the robotics and a little bit deep into controls, pneumatics, electric, mechanical stuff.
Gotcha. And if I want to ask maybe like a more general question when it comes to industrial robotics, so I guess at the top of my head, I know there's, the obvious ones like the arms that you see palletizing or moving objects. You also see, Delta robots with sort of like the 3 pivot arms that do high-speed pick and place. There's now the Boston Dynamics, right? The Spot robot, which TBD, I want to say, like on the use case, like when you say like industrial robotics, like what do you think of, and maybe like what are the general categories that you would put the devices into that?
Yeah, I think it's a very great question that you're asking, and maybe we can throw something out there. I think that the term robot itself became very popular overall. Like now we have mobile robots, then we have something called RPA, which has nothing to do with the robots that we define them. I think it would be very nice if we could, or someone could come up with some new nomenclature for like industrial robots, because it's very confusing. Even though I don't know if you guys ever tried, or maybe we have some headhunters listening, trying to find a robotics engineer. Like the moment you put it in, there is such a variety of skills required depending on what robot we're talking about. So I think it's a very valid question. So in my world, if I talk about robotics, I'm talking mostly about the palletizing robots and the 6-axis robots. So the robots that have 6 axes. I do also a little bit of delta robots. So everything that probably, if someone is not familiar, comes with like a kind of, let's say, heavy machinery. So the robots I work with would be limited to those. However, I think there are also like Cartesian robots, like gantries, which also sometimes are called the robot, even though it will have 1 or 2 axes. So if we're talking like about the robots I work with, mainly the industrial 6-axis robots are the Delta robots.
And that's a good point too. I had forgotten about, I guess, like MIRs or AGVs, right? Like also, because I think we bundle them into robotics, but ultimately they're like completely different. It's like worlds apart. You're just mapping like an area versus like executing movement from like an axis standpoint. So yeah, I like that point.
Yeah, and then also, even though if you go back in the history, like the very first device that was kind of called a robot was like a crane-like device that was programmed on a paper that has like a dots inside. You put it into the machine and it was just executing like pick and place application. And I think we can relate to that. But then if you go even farther back in history, there was devices called autonomous. So those were like dolls that would also make some movements. That was like Leonardo da Vinci times. So I think it's a very, very interesting word. And yeah, definitely like polishing and changing that into something that's more linked to a device would be helpful for, I guess, for many people.
And there's a good point in chat. I'll let Dave also jump in just a moment. But Stephen is mentioning, I think, that polishing and welding is becoming more normalized with robotics. The polishing application just helping a lot for quality of life, for having to use that equipment. So I guess like we could also think of like applications, right? Because I think like an AGV certainly can move things from one place to the other, but it would be more like relocating, let's say like a full pallet or kind of like raw or finished goods, versus like an arm is certainly not going to be used in those applications, and vice versa. So that's an interesting thought. I guess I've never thought about like classifying different robotics for sure. And your comment, even with the recruiters, I think it's interesting too. Go ahead.
Yep.
Yeah, absolutely. I was going to say to jump in, I absolutely agree with Pawel's comment. And I spend very little time thinking about it. About once every, 3 to 6 months, and certainly every year when the robotics theme comes around, I go and I look at kind of some of the robotics themes and go look at, the top X number of lists of robotics companies. And I feel like at some point, every time I go through this process, I Google something like top robot companies. And honestly, I just get a list of companies whose names that I have like virtually no recollection of. And I don't see any of the industrial robots as I have come to learn and expect. And when I see none of the top names of those companies, I know that I've done a poor Google search, right? And so going and searching top industrial robotics companies or top industrial robotics arms companies absolutely makes it a lot easier. And to Pawel's point, when I think about robotic arms, I think about 5 or 6 axis arms, right? I think about palletizing. To Stephen's comment that Vlad had pulled up earlier, I think about polishing and welding and kind of all of those very similar looking kind of robotics arms, as opposed to the gantry, as opposed to all of the other opportunities that we see. And so I think it is one of those we're almost blessed and cursed, right? We're almost blessed by the fact that there are so many monotonous tasks that we go through time and time again as the human race, that we're able to say, hey, how can I go build a robot to go do this? How can I go build a robot to make sure that I don't run out of whatever it is that I have on stock? And then from that point, it becomes a lot easier. And I think from an industry point of view, it's hey, if I'm talking about a robot, we're all talking about the same type of robots, despite the fact that the rest of the world may think of robots in completely different ways than our conversation. But Pawel, I would like to go dig a little bit deeper into some of the applications. So I know you said you've done a lot of work on the automotive side. You've done a lot of work in there. Can you talk about kind of some normal applications that you see, maybe some of the normal robotic arms, the brands, and maybe some of the differences that you're experiencing?
Yeah, of course. So my main background is a body in white. So that's where most of my work career has been in. That's what I've been working on. Besides that, I did a little bit of general assembly, as well as engine and transmission, a few projects in food and beverage. I think it all comes to nowadays more and more industries would like to put more robots in and automate more processes. But for now, body in white probably would be kind of a leading in quantity of the robots. And it has a lot of applications. So starting from such a simple application like material handling, which not necessarily might be very simple, going through spot welding in body in white, probably the second most common. Then we have gluing applications. Then we have roller hemming. We might have laser brazing, MIG-MAG welding. You can have rivets. You can have projection welding, which is just like a single electrode welding. You might have also a roller hemming application. And then if you go a little bit more into, for example, general assembly, you will have a lot of bolting applications or a lot of stud in body in white. So there's really then, like our guest mentioned, we have polishing. The robots are capable of handling a lot of various applications, and what we should always consider is like which robot brand would be the best for an application. Because what we're going to talk about in a second, as Dave mentioned, is I would like to emphasize that if a company would like to purchase a new robot, the application should be the first thing that will define which robot we should purchase. Because even though if you buy a robot, basically, let's put aside the programming. It's all about how easy would it be to implement an application on a robot. Does the manufacturer have some, let's call it plugins for now, that will enable us to make the use of this application easier? Is there something that is going to help us implement it and maintain it during our use of the robot? I think that from my experience, that is probably one of the leading issues that I found when I work with customers that are trying to start working on robots. To give you an example, I've been invited or working on a project once that was doing machine vision. So that was a FANUC robot with IR vision that was picking a very small paper clip and was putting it paperclip size piece of metal and was putting it in a very tight space. And what happened is somebody called, okay, we want to purchase the robot, we want to start integrating robots. So we know a little bit about the robots, but we don't know too much about the application. So the lead brand was FANUC, so they called FANUC and they say, hey, we want to add a vision system. And the FANUC said, well, great, we have our IR vision. You can buy the robot. It comes with everything pre-installed. You just connect the camera, connect the lights, and everything works straight away. You go through a very easy setup. Everything is ready for you, which is great for someone that's new because there is not much of a setup. It's kind of like a plug and play. Of course, you have to teach the machine vision, which is another topic. But from, let's say, integrator perspective or someone that's just new into the robotic is great because everything is ready for you. One thing they didn't ask or they didn't specify as a customer purchasing the robot is what is the size of the clip and where the camera will be located. Because somebody that's not familiar with the application, they won't know about it. So what happened is they ordered a camera and the lens that has very low resolution, and the camera was very far away. So basically what happened, the moment I snapped the picture and you would look at the picture, the size of the paper clip was like 3 or 4 pixels, which means basically like for a human eye, that will be like, if we talk in meters, maybe like 50 meters away. And that you would need to imagine you want to pick something that's 50 meters away with like a pair of like fingers, which would be very hard to do. And then the application became the nightmare because it was not clearly defined like what the robot should do and what is the application on the robot. So basically, long story short, we ended up changing just the lens to give it a little bit more zoom. So we were able to get it the image much bigger, so it would take more pixels, so it is more accurate to pick. And then what happens basically with others, I will speak with some of the customers that I have consultation with, and they'll ask me, well, which brand do you prefer? And I always say the same. The application will define the brand, because if you want to do something that's super custom, like you want to write your own functions, you want to create something that's very complex, I would suggest that you go with a different brand, because even though the user interface and operating and integrating this brand is much faster and easier for you as a newcomer, if you choose this and you spend a little bit more time learning about the robot, you'll be much more happy with the outcome that the robot will give you. So I know that in our team, you mentioned, Dave, that we were going to speak mostly about KUKA and FANUC. I would like to add also a little bit of an ABB into it, even though I have least of the experience with the ABB. However, I think it's enough to give like pros and cons and what I think should be the best. So if we go through, go ahead, Dave.
No, I was going to say, Pawel, if you are willing to go on record and talk a little bit about the similarities and differences, we are more than happy to talk about the FANUC and the KUKA and the ABB. We've got a bunch of folks in chat. I will say that if you guys have particular experiences about that, please feel free to go ahead and ask. We'll also say we're getting a couple of like very particular technical questions on robotic arms. I am not sure we'll be able to get to those, but we'll certainly do our best to answer them after the show. But no, Pawel, if you'd like to go share kind of the similarities and differences, that I think that would be fantastic.
Yes, of course. Like there isn't good or bad. Like you cannot say that one brand is better than the other. Again, it will depend on what you would like to accomplish and what your final goal is. Like it's kind of like you can buy an electric car or a petrol car, but depending on what your needs are, like if you have to travel 500 miles a day, you can buy an electric car, of course. But you have to keep in mind that you have to stop, charge it, and then go farther. So yeah, of course it's doable. But you can buy a petrol car, you just fill it up once, and maybe you'll be able to go the 500 miles in a single go. It's the same with the robots. Every robot can work with every application, but choosing the robot for the application will probably speed up the process and will result in a better or worse outcome for later on maintaining that robot. So I think we should also mention that I am a system integrator. Now you have to take a look at the robot from two perspectives, at least I would say. One of them would be robot integrator, which is like how easy is it to implement the robot? But if you think about the lifespan of a robot, that will be maybe like 1% of the robot lifespan, because the 99 is the robot working and maintenance or production, maintaining that robot. And that should probably define which robot you're going to choose. So based on its mechanical components, based on ease of access to the service, ease of access to the spare parts, ease of access to the support, and so on and so on and so on. So I'm going to focus on the first part, which is the programming, as I don't do so much of the support. I do production support, but it's not as often as the integration part and programming. But the integration part of the programming can greatly affect your maintenance, right? Because if the robot is not programmed correctly, then it's going to just lead all of the issues and drag them into your maintenance and production. So if you compare the brands like FANUC, ABB, and KUKA, for example, and so I'm going to very quickly stick with the maintenance. What I would advise anyone that is trying to purchase a new robot, especially for the new people, is to try to just contact sales people or try to contact support and see how responsive they are and see what you can get out of them. What suggestions, what options, how do they explain? Do you like the customer service experience? Because once you buy the robot, most of the companies will give you a warranty, and you're going to talk with them and ask them a bunch of questions, or you're going to ask for spare parts and so on and so on. So if that experience is not good, then maybe you should not choose this brand. Maybe you should focus on the other one. And then regarding the maintenance, you need to dive a little bit more deeper into what's the most changed components in the robots, which it will be either grease or oil. So that's something, or the batteries. Those are the main components that are, I would say, at least should be yearly changed. So of course it depends how much do you use the robot and what is the robot meant to do, because then if you have a robot that is dedicated for a food and beverage, then you'll have to clean it. If there is a foundry robot or it's a washroom robot, each of those robots will have different specifications regarding the maintenance. But again, reach out to the company and ask how much of a maintenance does the robot need and if you can handle it. So now if you go a little bit into the maintenance, for example, let's compare FANUC and KUKA. FANUC is using grease as its lubricant for all of the gearboxes. KUKA is using oil. So now, from pure maintenance perspective, it's a little bit easier and faster to replace the oil than the grease. But it doesn't really define which robot is going to last longer if you do the PMs correctly. It's more about doing those PMs on time, following the manufacturer specs, and doing what's recommended, because that is going to extend the lifespan of a robot. So that's what I would like to mention regarding this. And then also take a look at the accessibility. Like if you open the robot cabinet, see what part breaks most often, see how easy is it to replace, see like where the fuses are, see if you can get those fuses easily, see other parts, see how you can, are they easy to change, are they not easy to change. So that would be from, I would say, electrical and mechanical point of view. Now we need to go, if we still talk about maintaining the robot, production, and so on, we need to look into troubleshooting the regular production. So how are the faults displayed on the robot? Are they easily readable? Is there a description to the fault? Is there a remedy to the fault? And nowadays, most of the robot, whenever there's a fault, you'll just click on the fault and you can see the remedy for the fault. You can see what the fault is caused by, and you will have a fault code that you can Google, or you can ask the support. Say, hey, I got this fault. Let's see. Could you help me out? What does it mean? How do I solve it? And so on and so on. So those will be the things that I would suggest checking out before buying the robot if we think about it long term. Now let's talk for a second about the programming part. If we know the application, and ideally we are the expert in the application, and we know what is required from the application, then we should choose the robot. So if it's going to be a pick and place application that requires only taking a piece of metal or any element from one place to another, the brand probably doesn't matter. However, if you have to pick an element and you have to place it in a tight spot, or you want to do some kind of a check on it, or you want to see where you place it, or like you want to track the motion, you want to check some forces when putting the element somewhere, that's where we should consider which brand might be the most useful for us. Because we might want to write a lot of custom code. And this is another thing I would like to mention, which I've seen before. Robots should not be used to handle external applications. I'm sorry. What I mean is, I've seen a lot of cameras on the robots and a lot of vision systems. And sometimes people try to perform some mathematical calculations on the robot side instead of the camera. I do not advise, because the main goal of the robot is just to take it from place A to place B via some points. And if we can limit the amount of the logic that's being executed on the robot, it's going to speed up your process. It's going to make code a little bit easier to read. So if there is possibility of handling some logic outside of the robot, just do it. I would not say it's like a always thing that I would recommend, but if it's possible, just go for it, because it will speed up the robot process itself. So now if we talk about the availability of, I would say, source code, let's call it. If we compare the FANUC, ABB, and KUKA. FANUC user interface. So user interface is something that everybody is going to take personally, right? I might like something, but you might not. So I'm telling from my experience and probably a little bit of a maintenance experience. If you take a FANUC user interface, probably if we go FANUC, ABB, KUKA, it's the most simple user interface that you will find in the robots, because everything that you can do on the robot, you will do using the robot teach pendant, which means you don't need any additional software to program your robot. Of course you can, but you don't need it. Everything can be done on a pendant. So for some of you, that might be a pros. For some of you, that might be a con. If we take a KUKA, then you can do a lot on the pendant, but you need additional software to configure the robot, and probably you want to use it to write a code, because whereas in FANUC we have all of the options, all of the logical operators, all of the variables predefined and available on the robot, in KUKA we don't. So sometimes in KUKA you have to type in, you have a keyboard on the pendant, you have to type in your logical function. There is no, let's say, a pre-ready function that you can click, it will populate it, and you can just fill in the gaps. FANUC has it, KUKA doesn't. And it's similar for the ABB, where you have to write the code. However, ABB has a robot studio that allows you to connect the robot and change the code on your laptop and set it directly to the robot, which for someone that's familiar with like a C language and likes the option of using your PC to write the code, that probably will be a perfect solution. KUKA allows you to do kind of something similar, so you can edit your code and you send it to the robot, but it's not as, I would say, maybe not popular, but not as easy as you would have it in the ABB. So now you're coming into like, okay, what do I like? What do I think would be the easiest for me to learn? That would be the first thing. So the user interface. And then what is the easiest for the maintenance? Because, okay, you as a programmer are going to write the source code. The robot is going to execute it, but you're not the one that's going to be maintaining that robot every day. So I think that's something to take into the consideration. So I cannot say, okay, I like this the most because that's how I can program the robot the fastest. It's also like, okay, who is the end user? Is the end user going to like it? Is the end user going to do and maintain the robot and troubleshoot it quickly if I choose this or that or this option? Now, if we go to the code itself, each of the robots uses a different language. So FANUC uses KRL, KUKA uses KRL, and then ABB uses Rapid. For the user, when we have a FANUC, everything is kind of, I would say, it's kind of like a Windows for a robot. So everything is ready for you. You just click and play. So it's very fast to integrate because you don't have to spend a bunch of time trying to think if that function exists. Okay, what do I have available? You just click and everything is there. You just click it, integrate it, fill in the gaps, and the robot is ready to go. But the limitation is, because you have everything predefined, you cannot create your own custom functions. Now, before somebody in the chat says, well, you can, yes, you can. There is also an option of writing the code in a kernel language that allows you to create your own functions, that allows you to define your own variables, and so on, and so on, and so on. But it requires a little bit more deeper knowledge regarding the robot. So for day-to-day applications and maintenance, you would not change the kernel code. You would only work on what's already on the pendant. And most of the robots that you will get, probably you just want to have the solution out of the box. Now, if you go to KUKA, KUKA is more open source. So I would say it's more like a Linux, if you compare like Windows to a Linux, where you can change pretty much anything that you like. You can create your own functions. It allows you to do much more by default and see much more by default than FANUC will let you. So you can create the function in both of those robots. But in FANUC, because it's going to be coded, you cannot see it on the robot. So the file that you will create for the custom functions will be kind of, let's say, locked, and you won't be able to see that on the robot, which might be good for some of the integrators, because they would like to protect their source code from being used. So there is an option. In KUKA, everything is open source. You can also log your code that nobody will access it, but pretty much everything that's on the KUKA can be modified and can be adjusted to your likings, which can be good or bad. Because if you're unsure about what some of the functions are doing, or you're going to change something that is predefined in the robot, which you can, it might turn out that your robot won't boot up after you make a change. So you need to be very aware of the code. And then if we talk about the code, again, in KUKA, the code is hidden in under something that's called faults. So when you look at the robot code, you will see just a few lines, so it's easy to read. But in order to see what is really hidden inside each of the function blocks or each of the faults, you have to like open it and see deeply inside what's happening. So sometimes there might be some instructions hidden inside the faults that you might not see straight away, which might be advantage or disadvantage. Again, like if we talk about maintenance, we need to think about what they will be used to, right? Like they can learn everything. As long as they are aware that that's there, that's not an issue. But from a developer perspective, probably it's easier to troubleshoot the code once you put it on the robot, and you can change it on the fly. Instead, like for example, in the FANUC, you would need to, in order to debug, you have to change your source code and reload it to the robot. And then if we go to the ABB, I would say it's pretty much similar, the programming to KUKA, because it's also very open source. You can edit pretty much everything. You can define your own functions easily, and everything is accessible to you via your laptop. So like you can imagine having a Visual Studio to program your robot. So I think it becomes very handy. Now, which one is the best? Again, it depends on the person's preferences, right? One of you might prefer, okay, I want to do the Visual Studio stuff. But the other says, okay, we don't have so much time. Like we work in a foundry when it's very dirty. We want to carry out our laptops. I want to grab the pendant, so the device that you use to control the robot, just push a few buttons. I want to have everything handy and available. So they would say, okay, I want KUKA. I'm sorry, I want FANUC. So then we have to talk about the pendants. Again, it's going to be to everyone's liking. If we have a FANUC pendant, FANUC, at least for me, likely kept all of the buttons. So again, you can use the pendant to do everything on the robot, and you have the buttons, which means regardless of the industry, if you have gloves, if you have dirty pendants, if you have dust, whatever type of pollution, you will have a pendant, and you have physical buttons to push on the robot. If you go to KUKA, the KUKA has, well, if we talk about the newer model, so the older model, the KLC2 had buttons. Then they get rid of the buttons, and right now we have only touchscreen. What is great is like the ergonomic of the KUKA pendant, because it's big, you can see a lot of information on the screen, but it is only a touchscreen. So now it might be someone's liking or someone's not liking. If you have gloves, it might work, it might not work. If the pendants get dirty and you cannot push it, then it might cause an issue, right? And then if we have ABB pendants are pretty small, and they are also only touch screens. And one more thing about using the robots. So jogging the robot itself. So use the pendant to jog the robot. In FANUC, we have only options of using buttons. So you have the physical buttons to push that will move the robot. If we talk about KUKA, you have two options. You can use buttons, or there is also a 6D mouse that you can use. So imagine like a joystick to move the robot. And in ABB, the predefined way is a joystick that you use to move the robot. So again, someone might like this, other people might like that. Again, up to your preferences. Just keep in mind that those are the choices that you will be given. So those will be like the prerequisites to choose the robot. Define your application, define if you want to do a lot of custom logic or you want like a ready-to-go solutions. And now if we talk about ready-to-go solutions, something that I would like to mention, if we have anybody from sales, from any of the robot companies listening, I would like you guys to highly advertise and make your customers aware of the software options that robots have. So with the robots, it's pretty much like with buying a car. You buy a robot and you can buy options to it. So let's say you buy a car and you want to add, I don't know, some rear view cameras to it, or you want to buy additional mats for the floor. It's the same with the robot. You buy a robot, it will come with some stock predefined options, and then you can buy add-ons to it that might help your application. So you might buy a robot and you are not aware of an add-on that they had, for example, for, I don't know, arc welding. So you struggle a lot writing your own code, trying to create your solutions for communications and so on for troubleshooting. Whereas you might ask any of the manufacturers, hey, I want this robot to do arc weld. What options for arc weld do you guys have? So it will be very important for whoever is buying a robot, especially the first one, to like know, okay, I want this robot to do this, this, and this. Just describe what you want the robot to do. And that probably will help the salesperson to guide you to a better understanding of what the robot's capabilities are. I think that's a very big part that we're missing nowadays, and people are not aware. There's a lot of add-on solutions that are showing up on the internet that allows the robot to do more, to access them easier, to control them easier, control them remotely. But I think a lot of people are not aware that most of the robot brands already have those capabilities. It's just that the options are not there. Mm-hmm. So it's very important to know that this is on those robots, and it's possible to do something that you want to do without writing very complex code. It is already predefined for you.
Wow, there's a lot of really good information there. I certainly appreciate such a thorough walkthrough. I think that anyone who's looking to select a robot or is probably in the process of either integrating robots in their facility or maintaining them should definitely listen back to this episode. We'll make sure that it gets in the right hands. So definitely appreciate that. As a follow-up, I want to maybe take on the point of there's been a lot of robotic purchases in the year of 2022. I'm curious what kind of trends are you seeing in the industry in 2023, and also maybe like what kind of challenges is it? Like lack of parts? Is it lack of personnel that can program those robots? Are we like upskilling people enough? Is it maybe like something else? Maybe it's third-party applications. Like what kind of challenges do you see in the industry as a whole that would either get us to the next, like to an even higher sales record this year, or maybe to a lower one and we'll miss the target?
So I think it's sometimes very hard to predict what's going to happen with the economy and what's going to happen with the market. However, I think what happened in the past few years kind of showed that automating as many processes as we can might be helpful. However, we have to keep in mind that not everything should or can be automated. There are processes that can be automated, but the question we need to answer is it worth it? So to give you an example, like I had a customer once that is doing an application for deal sorting. So they have a facility where they process deal. So it comes in as part of like the oregano. They have oregano, dill, like many of the spices, and they do sorting of like leaves. And they wanted to do it with the robots. They want to say, okay, we want to automate it. And I'm like, okay, so like, how much does it cost you to do it by hand. So they give me a number and it's like, okay, so you have to be aware how much does the automation cost. Like it's a long-term investment. So if you're doing it, you have to be aware of like, you're going to spend a lot of money right now and you're going to save a lot of money later. I think the biggest issue for now is lead time. So people are very urged to automate, but there is not too many parts available. Even if we talk about robots, even if we talk about like electrical components, SIO blocks, MIO blocks, all of those are just not available on the market. So if you want to purchase high quantities, you have to wait a long time. So maybe in some cases people will say, okay, too much of a wait. We don't want to wait. We want something that's ready to go. I think overall the sales will keep going up and the numbers will be going up because as consumers we want more, faster, and better. So like going with automation is the way of going faster and better usually, because we're able to do the same process usually with better quality and faster. Because the robots, for example, if we talk about them, they are made to do the same process I'm sorry, many times, and they will repeat it with the same quality every time. So that will go up. If we talk about skill sets, and people to program the robots, I've seen personally there is a big difference if we talk about the robot industry and like robot programmers between Europe and USA, for example. So I spent half of my working career in Europe, then another half around the world, majority of it in the USA. And what I've seen is, whereas a few years ago in Europe, there was a very clear difference between the robot programmers and the PLC programmers, I do not see that in the US. So I see that people are aware that there is robot programming and PLC programming, but in here it's mostly called controls. And controls is a person that does it all. So it does the PLC side, it does the robot side. And I'm a little bit worried that we're heading the way the IT is heading, where you have a software engineer that has to know 24 different languages, but programming in each of those takes the same amount of time. So yeah, you have one person that can do a lot, but the time factor stays the same. So okay, it's great to have that option. It's great to know both. It's great to know PLCs and the robot. But we have to be aware that the time factor will stay the same. Yes, knowing the fact that somebody knows robots and PLC doesn't mean something will be done faster. It just means it will be done cheaper because one person can do it, but the time is going to stay the same. Maybe even the time is going to be longer because once you become, let's call it expert in your field, then the time you need to execute something is becoming shorter. Now, if you have two fields to master, mastering both of them takes more time, and then it will take more time to program. If you're like a company that is buying the first robot, yeah, of course, you're not going to hire a robot programmer just for one robot. You're going to teach your employees how to operate that robot. But if we talk about somebody that already has a few robots in their factory, it very depends. So I've been to many projects. I've been to some factories that have hundreds of robots and they have one robot engineer because there is no more needed. Because the application is programmed so well that the robot is able to handle everything that happens inside the station, or like, let's say 99% of the cases. And there is only 1% when somebody has to go to the robot and actually touch it. So it again goes back to the application phase and choosing the robot brand and what you want to do with it. Because if we talk about pick and place application, let's focus on those. Most of the robots can be programmed to return to home. Home is like a starting position of the robot and can restart the cycle, theoretically, whatever happens. Of course, if you hit something, yeah, somebody has to go in, fix the obstruction, move the robot out. But in many cases, let's say the robot will fail to pick, and now it will be the role of the programmer to program in the way, okay, robot failed to pick, let's pop up something on the screen, to the user, like, what do you want to do? You want to try to repick this item, you want to reject this item and move the robot back to home, or so on and so on. I worked on many projects where this was the main focus of the customer. They say, we want a solution that we don't want to touch. So you want to implement it, you want to troubleshoot it, you want to test it, and you want to leave it to us. We don't have any robot guys, so we're going to call you guys in case something happens. And those applications are definitely doable. Is it recommended not to have anybody on site that knows robots? Probably not. It will be good to have at least basic knowledge, but that's where like online trainings would be enough to handle your robots on site. But it will all go back to the phase of the implementation and understanding what the robot is capable of. And depending on the brand that you choose, it will be easier or harder to implement those, let's call it, recovery solutions. So if you buy the robots again and you ask for the software options, you want to make sure that you can have remote access to the robot. All of the robots have this right now. So, like, for example, there's a lot of customers that will contact me and they say, well, we have the issue with that robot, we want to change that code. I'm like, okay, so let's go in. I can remotely log in onto the robot, see what's happening, and advise, okay, do this or do that. Or even like implementation, like I'll send them a program and they said, okay, we like it, but we don't like this. I'm like, okay, let's run through the code, let's see it. And like they do it on the screen, I see it from home what they do, and I have to be on site. They didn't have to spend money on travel expenses. So the service becomes faster, more accessible to the customer, and also at a lower cost. But again, it will go back to purchasing the robot and like, have you purchased the option of remote access? Yes or no. If you didn't, well, then you have to now pay for specialists coming your way. Mm-hmm. So I know that kind of floated off the topic, but if we still go back and talk about the people that are doing the programming, I think it will depend on the company. The robot's job can be like a side hustle in means of like you have a controls engineer and he learns it just to do pick and play applications. If the application is simple enough, I would say you don't need a robot programmer. Like, also, what I would like to highlight, robot programming by itself is not something that should be considered as I would maybe not sell it as a job, but like the robot without any tool is just a piece of metal. It serves no purpose, right? You might be the best programmer, but if the robot has no tool, there is nothing that the robot will do. The moment you mount the tool on the robot, that's what is going to define if you're a good or bad programmer. What can you do with that tool? So you have to be aware of the application that you're going to use, and you have to be aware how the robot can behave with that application. So if you take, for example, spot welding, right? You put a spot welding gun on the robot. Okay, are you aware what is like a gun compensation? Do you know how to approach a spot weld? Do you know what should be the distance from the spot weld to a fixture or to any obstructions? What will define a good weld? Is it the angle? Is it the pressure? So knowing just the robot nowadays is not enough. You have to have some second set of skills. Usually application will help a lot. If you know controls, okay, you can do pick and play, let's say, application, and you will become, we can talk about this a little bit. I divide programmers onto like three main categories, which would be like robot driver, robot programmer, and then robot expert. And depending in which category you will fit in, that was going to define whether or not you can do just robot programming as your job, or should it be only add-on to your set of skills.
Well, let's take a pause on that, because I think those definitions are definitely interesting. I want to mention before we go into an ad read, so Michael had a bunch of really good points, one of which was that Rockwell can now allow you to do motion on robotics using PLCs, but that's going to be a question right after the ad read, which is going to be us exploring, I want to say, third-party applications when it comes to robotics. But before we get there, Dave?
I want to say, everyone, short-time, long-time listeners, this is a momentous occasion. We're only 133 episodes in, and Vlad realizes that we have to do an ad read. So this is amazing. It may be super self-serving because We would like to thank Solus PLC for sponsoring the robotics theme. If you're an engineer or a technician looking to break into industrial automation or upskill, Solus PLC is your go-to resource. They've got these super in-depth tutorials and online courses that cover all the nitty-gritty from PLC basics to HMIs and even robotics. And the best part, you're learning from the people who actually do the stuff for a living. No textbook nonsense, just real-world skills that you can use. Thousands of students from companies like General Mills, Amazon, and Tesla are already getting ahead with Solus PLC. So whether you're a pro or just getting your feet wet, there's something for you. What are you waiting for? Head over to solusplc.com and get learning. Vlad, I'm going to go throw it over to you because I know you guys have launched some robotics courses. I don't know if you have any comments on the robotics courses for anyone who might be listening right now.
So I think we have the perfect person to talk about the robotics courses. So Pawel has built a lot of them. Pawel also runs Future Robotics, the channel on which we're streaming as well. So again, based on the conversation we've had thus far, a lot of experience, a lot of knowledge. And so all of that has been incorporated into the courses. Pawel, do you want to maybe give a brief overview of what's available?
Yes. So we're still developing the robotic courses on the Solus PLC. For now, we focused on the basic FANUC introduction that allows people to learn basic of the FANUC robot. So if you have never touched the FANUC robot or you have been working with other robot brands and you would like to get familiar with how is it to program FANUC, I think that's a perfect course for anyone that would like to get like hands-on experience using a virtual environment that allows you to learn the basic of FANUC programming. We also launched the second course regarding robot DCS that allows you to understand the basic of the robot DCS for FANUC. So DCS are safety functions that are incorporated into FANUC and can be purchased as an option that I spoke about earlier. So if you're curious why your robot stops when you cross a light curtain, or if you're curious why your robot stops when you open the gate, all of this is being explained in the FANUC DCS course. And we have more courses coming this year. We're also open to any of the suggestions from our viewers. If there are any courses that you guys would like to see, or if there are some topics that you're interested in, feel free to drop it down in the chat or send an email to Solus PLC. And we're going to work on those courses as we can, and we're going to show them on the platform.
I will make the comment, Pawel, and I guess like I only found that out after a conversation we had together. DCS, I guess it stands for two different things. So in the world of controls, distributed control systems, and in the world of robotics, dual channel safety, which can also be in the safety side, but something I had not realized when you were putting that curriculum together. But I think it's an interesting fact, I guess, for those of us in controls.
Yes.
Without any further delay on that, so if you want to check out Solus PLC, I will have a link for you in the chat. That being said, if we want to go back to robotics, Pawel, so the question, I guess the comment that Michael had made and that I briefly alluded to was that Rockwell can now do coordinated motion for robotics inside of the PLC. And I think that, like if I can expand on that a little bit, I think we see a lot of different third-party tools that either allow you to simulate or allow you to, I guess, create a program that you can then put on the robot without the native, like robotic application. So I wanted to maybe like get your thoughts on, like, is that where the industry's head? Are PLC programmers now going to write code in the PLCs to control the robots? Do you think these like third-party tools are useful, make it simpler maybe to program? Like, do you see some clear advantages on the market today?
So regarding the question itself, I have not personally tested. However, I think it's a valid point. But the question or the statement I would like to make is kind of referring to what I said earlier. Robots itself are made to move from point A to point B the fastest they can. The less logic and the less workload of thinking what to do on the way they have, the faster they will move. One thing also that would make a difference between a controls engineer and a robot engineer, which I personally see as the biggest difference is when you're programming a robot, you will deal mainly with motions. And you have to be aware of how a motion or how a logic is going to affect your motions. So if we talk about cycle time, which probably is one of my favorite topics and one of my favorite actions that I will do on the robot, sometimes we are unaware how moving one line of a logic will affect the entire process and the entire movement of the robot. So again, if we talk about very simple pick and play applications and using PLC to control your robot, sure. But if you want to squeeze out everything that's possible out of the robot to make it as fast as you can, as optimal as you can, and you be as proficient as you can, I think this will become a limitation because there is still data that has to be sent over from the PLC to the robot. So there will always be small delay. And then again, one thing that is not being considered is the motions itself. So if a robot is moving through 2 points and there is a logic command in between, that logic command might or might not affect the movement. So now, I don't know, you might be able to control your motions through the PLC. I'm not quite sure how that's being done currently, but this is the question. How is it going to affect those motions? Is it going to slow them down? Is it going to speed them up? Is it going to allow you to manipulate those motions the way the robot allows you to do it? But if we talk about those third-party applications, the way going forward definitely is simulation and virtual commissioning. That is a topic I've been mentioning for quite some time, probably like starting around 3 years ago. I said in the next 5 years, most likely, the job of an on-site robot programmer, as we understand it now, so a person that comes, commissions the robots, will be very limited. Everything will be done in a virtual environment. Everything will be pre-programmed. You will only come on site and implement the solution that you've integrated in a virtual environment. This is the way and the path forward for making that process even cheaper and faster. Is it possible right now to implement everything or test everything virtually? Not yet, but definitely we're on the path of doing that. Just to give you a quick example, I worked with a customer very recently that asked me to remotely support them. So just with the ability of being able to remote in to the robot, I sent the programs, I installed the programs, and I've done pretty much everything except for cycling power the robot, which is required for the someone that has the robot to do. You cannot cycle power remotely. Technically you can, but let's say you cannot, just for the simplicity. And the second thing you can but really cannot do remotely is to touch up the points. So you need somebody that will go there. Even though I send the program, the robot will execute the motion. Maybe there is a slight adjustment that has to be done. So I've done everything remotely. Yeah? I've done everything using an offline program. I program it, logic, settings, everything. I created a file that I gave it to the customer. I said, okay, that's the file we're going to use. Let me remote in. You just put the USB with the files. You can even send those files remotely to the robot. That's also possible. But I said, I gave you the files, so you have them for future reference. So just put them in, hit enter, everything will be loaded. You just have to touch up a few points, and that's all. So the solution that he wanted to use, but we didn't succeed, was using like virtual goggles. So he wanted to put the goggles on so I can see his hands and I can see him manipulating. And I think that's the way we should be going. So if there is a service, you have already the remote connection available on the robot. Somebody just put in the goggles and you see what the person sees and you just navigate him through the process. And now, because some of the remote connections allow you to click the buttons on the pendant or like navigate through the robot, that means you're limiting the needing of the knowledge for someone that's in front of the robot to only like push the buttons if needed to jog the robot. Everything else can be done remotely. So you're going to troubleshoot the robot, change some settings, and say, okay, it's good to go. Just push this and this button, and then push start. I think that's the way that industry is heading.
Well, if I may throw a question at you
Yes.
on that, What kind of tools, I guess, are you using? Are you using native, like FANUC, KUKA, ABB
Yes.
tools, or are you using any? So, again, I'm not extremely familiar with the space, but I know Robotics has a solution. I think like Siemens has some kind of a simulation solution. And if I'm not mistaken, Vention, on top of just providing the cells, also has like a simulation tool. Like, do you use any of those, or are you using the native tools?
So I use the native tools. I work with the customers mostly with FANUC. Mostly using RoboGuide, as that's the tool for FANUC. But for the remote connection, none of this is needed. So the tools that you mentioned are needed to create the programs, yes. But to do the remote connections, you don't need anything. All of the robots has, let's call it stock availability. You have the option to just remote into the robot and do whatever you like without any additional software installed on the PC. Maybe let me rephrase that. You might need to install again some Excel file that will allow you to handle some of the plugins that the robot is using, but you don't need any extra knowledge. If you know the robot, that's all you have to know.
Gotcha.
The software that you mentioned, they allow you to do very different things. So like process simulate. So there are tools like process simulate, there is Delmia, there is RobCat. There is quite a few softwares that are used for simulating not only the robots, but entire lines. So if we talk about simulating entire line, including PLCs, you can use software like, for example, Siemens Process Simulate, where you can simulate pretty much everything from the movement of people inside the station through conveyors, or clamps, part presence sensors. The entire process, together with virtual commissioning, can be done on those platforms. So nowadays, for example, if we do a buy-off of the line, everything will happen first in a virtual environment. So the customer might create everything in the simulation. They'll send you, okay, this is how the simulation will look like. That's how your robots will move. Then let's say you say, okay, I like it. Let's go to the next phase. The next phase, the customer will call to you and say, okay, everything is done according to your spec. Let's review the virtual commissioning. And what you would do is you can click anything. You can simulate anything, a part present fault. You can simulate a clamp faulting to close. You can simulate opening a clamp during the process and see how your station is going to behave. And you can predict a lot of scenarios before you put the line in. That's why I'm saying the on-site programming will be going like more and more as something that will be done within like a month or within a few weeks. So definitely virtual commissioning and simulation are the path forward. If you ask about the other softwares like Robotics, there is also Rhino. Those softwares, there's also Grasshopper for KUKA. So those are the software that allow you to program the robot in an easier way. So more like block structure. Some of them will allow you to simulate, but just the robot process without additional elements. It's all up to what are your requirements. What do you want to do? Do you want to simulate the entire line, production line, or do you just want to simulate the process? You want to do, let's say, polishing. So you don't need like a very expensive software. You just need a software that's for the robot, and perhaps that's all that you need. So yeah, there is a lot of solutions. Each of them will address the different issues. So again, it will depend on what would you like to get out of that software. But definitely nowadays, I don't see a process in nowadays, and like in the rush that we are in, I don't think it's affordable not to do the simulation. I think it will cost too much money to send somebody on site to do everything on there. Everything should be prepared, unless of course you have plenty of time and you're buying a robot and you are new to it. Yeah, probably you want to do that learning curve to get familiar with everything. But nowadays, if you were contacted by a company, by an integrator, if they then offer simulation, that means that service probably will be a little bit more expensive than just sending like on-site programmers. So simulating, for sure, the way to go.
Dave, what are your thoughts?
I think it's interesting. As all long-time listeners and now all short-time listeners know, they'll know that I'm very excited about simulation, right? For all the reasons and more that Pavel is saying, it seems like, especially if this is going to be a repetitive process, if this is going to be a process that we're going to have to take the line down or is very critical to what we're doing, there seem to be more and more reasons that it logically makes sense to go through the process of simulating this before. And I am excited as to when we outside of the very repetitive processes come into that simulation. So I'm excited to get more hands-on use with it with a bunch of the different clients that I look like. Pavel, I'm going to go move us towards kind of all of the last questions that we had to everyone. But I know that one of the topics we wanted to talk about was to talk about careers and skills and people, if people are interested in either learning how to program robots or learning to upskill what they can do within robotics outside of the SolusPLC.com robotics course. What, in your opinion, are some of the best ways they can do that?
So I definitely think a good starter, there is plenty of videos available on my channel or on YouTube that will give you an introduction to what the robot is and how to program it. I think it's a very good supplement to before going onto the robot, or if you have the robot on site, that can speed up the entire process of using the robot. So if somebody has no knowledge, start outside, like you said, outside of the Solus PLC, just go to YouTube, watch some tutorials, and learn some of the basics. One thing to mention regarding the tutorials itself is like some are good, some are a little bit worse. Like it's for the user to decide whether they like it or not. But at least you're skipping kind of reading the manual. Like what I would do before there was anything on YouTube, there was anything available, the best books that are available for the robot programming are the manuals from the manufacturers. The best thing about them is like they will have like 600 pages. So you have to know what to read, what you're interested in. But that is actually the best way of learning. It's just very long process. So if somebody offers this like on the online courses or on the videos, that will save you time from reading the manuals. I will still highly advise to read the manual. Those are the best books that you can get for robot programming. But if you want to just have a quick start with the robotics, just go on YouTube, watch some of the videos. They will give you an idea how to program the robot. Then we have the education at colleges, universities. You can do that. They will also teach you some of the basics. After that, you can get hired as an intern or you can get hired by a company, and then you'll get the hands-on experience, and that's where the real learning happens. Because once you get onto the robot, once you push some of the buttons, first, I also strongly suggest to use all of the simulation software available. You have for FANUC, you have FANUC RoboGuide. For KUKA, you have KUKA Sim, and that you can use that will show the robot, and you can simulate its environment. So you will get ready. And for ABB, you have the Robot Studio. They will represent the actual robot. You will see the pendant. So you will see everything like in real life. You'll push the same buttons. Even for ABB, you will move the robot with the joystick just on your laptop. So get ready before you get the robot. Listen to a little bit of the YouTube, read a little bit of manuals, and that will kickstart your career in that field. The thing I just want to mention one more time, while you do this, it's very good to learn a little bit about an application that the robot can do. If it's going to be just material handling, then there is not much to learn. In theoretically, yes, you should know like what does it mean to over constrain a part when you grab it, because then it can cause an issues with pig and plate applications. Like if you over constrain and you're trying to drop something onto a datum pin, it might cause an issue of like the part jamming against the pin. But that's like where we go into the details. But if you want to do pig and place, probably learn a little bit of a PLC, and that should be enough for you to start a career in robotics or per se controls field.
No, awesome. I think that those are all very good places to start. Now I want to come to one of my most favorite questions as to come and ask you to predict the future. And we do see that the name of the channel is Future Robotics, and you are wearing the Future.
Sounds like we lost Dave there for a second. So
Yes.
I guess I will shorten, or I guess give you the question, Pavel. So we are looking for a prediction of the future when it comes to the industry of robotics.
Yeah. So I think I kind of already mentioned and touched on that topic. I think simulation and VR are the ways to go, at least with the current state. I know everybody will ask about the AI. I think there are fields to explore, but I would say that as of right now, AI should be used for the applications of the robots, not for the robots itself. So what I mean by this, if we have like a vision systems, well, let's leave the machine vision on the side and let's explore the AI vision, because it allows us to do more than just the machine vision. If we have spot welding, let's input some AI into it, how to optimize that process. Most of the weld controllers right now will give you a lot of feedback regarding the weld itself and optimizing the weld. But if we put a little bit of an AI into it, then we're taking out the human out of it, and we allow AI to learn it and then optimize it. So let's say an introduction to AI is kind of like adaptive welding that we use for spot welding. That's kind of like learn and then adapt. So I would say let's leave the AI for applications, and let's focus right now on simulation and VR. Those should be the way, from my perspective, to go. So because those will allow for the robot industry to grow. Because the moment you feel safe that, okay, we bought a new robot, it costs a lot of money for a contractor to come on site. We have to pay all the expenses. We have to pay for everything. We have to wait. We have to check the availability. And now it becomes more of like, okay, we can call any guy that's anywhere in the world and he can help us out. We just need that option installed on the robot. I think that will encourage people to purchase the robot, because they will see it as, okay, that's an application that can be handled now from anywhere. Of course, there will be cases where, you have to go on the site, but I would say 80% of the cases you could use a remote support. So VR, remote support, simulation, and let's leave an AI for the robotic application. That would be something that I think is going to happen, or it actually is happening already.
I love that. I think that is a very exciting future. So Pavel, we like to, for all of the folks on Future Robotics, we always like to ask for some content recommendations. So if people have watched this, they like what you're saying, we know we can go ahead and send them over to the Future Robotics YouTube channel, which Vlad has in the chat for everyone. Send them over to some of the Solus PLC courses you're having and are creating. But beyond that, do you have any other very interesting content recommendations that you would suggest?
If we talk about the robots, I would say it's good to watch what companies are releasing in terms of their built-in applications. Mm-hmm. So if you choose any of the brands, FANUC, KUKA, ABB, any of those brands, explore what are their main applications and what are the plugins that they have allow you to do. So, for example, to give you, that's something that KUKA implemented long time ago for aluminum welding. I forgot the name, so I don't want to say the name, but basically for aluminum welding, they implemented, or just for this welding, steel welding as well, basically for welding, they implemented a solution where the robot will close the gun and then it's going to twist clockwise or counterclockwise during or after that weld. So that's the functionality that the robot will have once you buy it. You don't have to think, maybe somebody that's a specialist in joining and welding application, they'll say, well, we need that because of the type of the material that we're using, the steel that we're welding, it's sticking. We need a solution to weld it easier. So explore that on the robot website, because they might have something that you want to implement and you don't need any special instruction, any special logic or anything extra. You can buy a ready solution, so why not try it? So if you go to any of the websites, FANUC, KUKA, ABB, see what they work with, what are their applications, and what add-ons they give to you.
No, that's fantastic. Thank you. And last question for you, Pawel, is who should reach out? Who do you want to connect with? Who are you looking to talk to about technology things? Are you looking for new customers? Kind of the open platform for everyone, for all of our listeners. How can they help you?
Sure. If anybody is interested in integrating new robots, feel free to contact. I'm happy to help. Even with simple questions like, we want a new robot, but we have no idea what to choose. It's asking or researching before you buy it. I think it's worth every penny, because it might save you thousands of dollars later on in the future if you choose the robot that's good for your application. Then anybody that would like to develop a new software for robots, or is interested in developing or working on any of the platforms, FANUC, KUKA, ABB, also feel free to contact me. And if anybody has any feedback regarding the robot itself and would like to just chat about it, also I'm open to discussion and questions.
Awesome. No, thank you, Pawel, and thank you everyone for hanging out with us. This has been Manufacturing Hub episode 131. We are talking about robotics all month long. If you have made it this far, please feel free to connect with Pawel, myself, Vlad, follow Manufacturing Hub and Solus PLC and Future Robotics. If you made it this far in podcast format, please go hit the 5 stars and like. And everyone, please feel free to go ahead and make sure to like and share this. As I tell people every week, Pawel, I ask people go do it, and then our numbers continue to climb. And so I'm going to continue to do it until it stops. But until next week, we'll see everyone soon. Thank you.
Thank
Bye-bye.
you, guys.
Everyone. Thank you, Pawel.
Thanks. Bye.